Hello everyone. For this tutorial video, I'd like to show the circumference and area of an ellipse, which can be derived both from the equations related to the circle and the Pythagorean theorem. Geometrically, an ellipse is a shape that has a continuously smooth curve all around, just like a circle. However, an ellipse does not have the same rate of curvature all around. It has wider curves in one section versus another. Similar to how rectangles have greater lengths in one section versus another. Because we proved the circumference of a circle is 2 pi r, this is exactly as true for an ellipse as well, although because it does not have a constant radius, the formula for r will be slightly more complex, meaning the overall formula will be more complex in turn. In particular, we can derive this by drawing two straight lines that intersect each other at a 90-degree angle, and that both meet at the center of the ellipse. If we are creative about this, we can see that these two lines are good candidates for the straight legs of a right triangle, and that the slant of the right triangle these make up would be exactly equal to the radius or distance from the center by definition of what a radius is. However, only half these intersecting straight lines will constitute the straight lines of a right triangle at any given moment because of the way the right triangle works. So the radius would be a squared divided by 2 plus b squared divided by 2, and then the square root of all of that. Now that we have figured out what the radius will be at any moment, we can plug this into our formula for circumference, and the circumference of the ellipse would therefore be 2 pi times the square root of a squared plus b squared all over 2. And by the same exact logic, the area would be pi times a squared plus b squared all over 2. We can actually verify that the Pythagorean formula trick works for circles as well, by drawing two lines that are straight and meet in the middle at 90-degree angles, so that the circle is cut into quarters, and noticing in this case that A and B have the same exact length, which was not true for an ellipse. So we can state that radius equals the square root of 2a squared all over 2. And 2 over 2 cancels out and we get 1. And the square root of something squared also cancels out. So our final answer is that the radius is a constant, which is what we already knew by intuition, but we should still prove it rigorously to be extra sure. Now that I've explained how the area and circumference of an ellipse works, I can teach how to work with sectors of circles or ellipses, and a special formula you can derive for them.